So in question 3, you're asked to write each of the following complex numbers in the form a plus bi, where I squared is minus 1. Now the first few of these are distribution questions. The fact that there's complex numbers there means that you make one little change to how you answer it near the end of the questions. So if you're comfortable enough with algebra, you should be comfortable enough with these types of questions as well. So you answer this by distribution. So the way I do this is I say the 3 from the first one gets multiplied by the second bracket, so it's 2 minus 5i, and we end up with a 2i next, because that's what's left in the first bracket. That also gets multiplied by 2 minus 5i. So we just follow along the distribution. We end up with a 6 minus 15i plus 4i minus 10i squared. Now this is where the change comes in, the fact that they tell you I squared is minus 1. That's the only change you make to these distribution questions. So I'm going to make that change now. Keep everything else the same. And where I see the I squared, I instead put in a minus 1. So that becomes a 6 minus 15i plus 4i plus 10. And then we can start grouping these together. So 6 plus 10 is 16. And minus 15i plus 4i is going to be minus 11i. And that's the end of that part of the question. The second question here has really two ways of going about it. The first way is a factorization thing where you say the 17 minus 3i appears in both of these terms, so you can take that out as a common factor, and then this question gets very, very simple very quickly. So let's try that first. So we got 17 minus 13i is a common factor, and what we're left with goes in the other bracket, so that's going to be 5 plus 4i. And now just be careful with the signs here. This is a minus 5 and a minus 3i. So at this stage, if you want to, you can distribute. I'm not going to yet, because I noticed that I can simplify this second bracket. I've got a 5 minus a 5, so that's just a 0. And I've got a 4i minus a 3i, which is just I. So now this question is a whole lot simpler. There's just like a tiny bit of multiplication to do. So now we got 17 times I makes 17i. And then minus 13i times I will be minus 13i squared. And just as before, we have to make sure that the I squared becomes a minus 1. So the result of that is just going to be a plus 13. I'm going to put that at the front because that's kind of the typical way you do it. And then you add on the 17i as well. Now, the second way of doing this is a lot harder, unfortunately. If you don't spot that there's a common factor here that you could take out, it just ends up being a distribution question where you've got two separate distributions to do. If you want to do it that way, one thing I just recommend is put some brackets around each of these just to be clear that each bit is done separately, and to make sure that this minus sign here in the middle actually gets factored into everything on the right hand side. In part 3 now, we've got a lot of fractions, unfortunately. If you're not really happy about these fractions, there are ways of dealing with it. Say you could take out these halves as a common factor, apply various rules of indices, and you end up just kind of leaving it to the side until the very end. Now, you cannot get rid of the half. It has to come in somewhere. The best you can do is leave it aside for a while. I think that will overcomplicate it though, so I'm just going to go ahead, barrel through this the normal way. So this first one here, let me simplify this. The square means essentially multiply the bracket by itself. So it's another kind of distribution question. If you're familiar enough with how to distribute these squares, then you don't have to do this step. You may already know that there's kind of a formula for getting it done. I would rather just kind of barrel through it, just make sure that we have all our bases covered, that we don't make any mistakes. So what we have here is the first bracket multiplied by itself, because that's what the square means, and we have the second bracket multiplied by itself as well. So what we're going to end up with is 25 over 4 we're going to have a 35 over 4i, another 35 over 4i, and then a 49 over 4, and that's going to be an I squared. With the second one, we're going to end up with 25 over 4. We're going to have a 5 over 4i, another 5 over 4i, and lastly a 1 over 4 times I squared. So the way we handle this is we can kind of group similar things together. Of course, this 49 over 4 times I squared is eventually going to become minus 49 over 4, because the I squared is minus 1, so I'm going to kind of do that right away. And then I'm going to stick everything else on the end. I want to keep my real numbers together and my imaginary numbers together. I'm going to do the same with the second bracket. So we got 25 over 4. This 1 over 4 times I squared is of course going to become minus 1 over 4. Because of that, I squared becoming minus 1. And again, I'm going to group together my imaginary parts. So the 25 minus 49 is going to be minus 24 over 4. 35 over 4 plus 35 over 4 is going to be 70 over 4. And don't forget the trailing I there. And the second bracket, we're going to have 25 over 4 minus 1 over 4. That's going to be 24 over 4. And we've got a 5 over 4 plus a 5 over 4. So there are 10 over 4 i's. And lastly, just to clean this up, we got a minus 24 over 4. This is going to be minus 24 over 4. That leaves minus 48 over 4. And we have a 70 over 4i minus 10 over 4i. Don't forget that this minus is going to affect the 10 over 4 as well. So that leaves us with 60 over 4 times I. You could kind of leave it like that if you want, but we can simplify this further, because 48 divided by 4 is of course 12. So we end up with a minus 12. And then 60 divided by 4 is 15. So we get minus 12 plus 15i. Now the last part of the question is relatively straightforward. The 1 is just going to be a 1. I is just I. I squared we know is minus 1. The only bit that you might have a little bit of trouble with is the I cubed. So let me rewrite this as I squared times I, because that's what I cubed is. It's I times I times I. So we can group together two of them, get an I squared. So I'm going to change that to a minus I. And of course the result is 0. We have a 1 minus a 1. We have an I minus an I. So the result is that we don't really have anything. Now the very last bit of the question, part B, asks which of Z1 and Z2 above is farther from 0 on an Argan diagram, and we have to justify our answer. So just recall that Z1 was 16 minus 11i, and Z2 was 13 plus 17i. Now, you may be able to tell this straight away, but the fact is we have to justify our answer, and we do that by actually measuring or calculating how far each of these are from 0 on the Argan diagram. Now we have a formula for this, so first of all let me just get the coordinates of these. We've got 16 minus 11, so as the real and the imaginary coordinates. For Z2 we have 13, 17, and the formula is essentially Pythagoras' theorem. The way we write the length of Z1 is like this. So it's Z1 with a line either side of it, a vertical line. So that is the square root. Take each of the components and square it, and then you add them together inside that square root. So we're going to get a square root. That's going to be 256 and 121. And so you add those together, you get the square root of 377. You can leave it like that, or if you want to, you can sort of approximate that to 19.4 or thereabouts. So now we do the same for Z2. So we have a square root, each of the components gets squared, and then added together. So 13 squared is 169. 17 squared is 289. And when you add those together, you get 458. And again, if you want to sort of deal with that a bit further, that's about 21.4. So that's proof enough. We can actually then just say this is good enough reason to say that Z2 is farther